Alright, here we're going to look at different ideas behind organizing and displaying data. So first, we're going to look at frequency distribution. So a frequency distribution is essentially taking your data and organizing it, and then being able to do a count of your data based on how often a specific data point is occurring. Now we can group or classify your frequency distribution based on what are called your lower class limits or your upper class limits. And those essentially give you what's called the width of your class. So the width of a class is the individual size. The class would be the unique set of data for a specific category. Your lower class limits are going to be the lower values of your class designation. So in other words, your left hand side values, and an upper class will be your right hand side values. So because that's a very unique thought process, here I have a listing of some different class limits. So in order to understand what's going on here, first and foremost, we have to calculate the class width. Okay? And so one of the things that we're looking at is we are looking at the number of data that shows up in your class. So to find that, we have to think of each data point as its own separate data. So the easiest thing to do is you can look at, say, all of your lower class, and you can take and subtract one of your lower class from the other. So for example, I would do for my width, 15 minus 0 is 15. So here my width, and I can say based on lower class is going to be 15. And it would be the same if we base it on the upper class. If I were to do 29 minus 14, I'd come up with a difference of 15 there as well. Now that being said, I can go ahead and list my lower class limits, and those being essentially all of my left hand values. So 0, 15, 30, and 45. And then my upper classes, so my upper class limits would be that right hand side. So 14, 29, 44, and 59. Okay. So when we're talking about just simply listing the classifications for your frequency listings, this is part of what we are getting at. Now another way that we can see your data is in the form of tables or histograms. And so one of the things you have to make sure that you pay attention to is the type of table you're reading. So you can look at bar graphs as well as many other forms and be able to come to the same conclusions. Now, sometimes we are given a data table of data. And in this particular one, we are looking at grades for a first test, and we want to construct a frequency distribution for the grades. So the way that we do that is we have to look at what are all of the grades that we've been given. Well, we have A's, B's, C, D's, and F's. There's no other letters used. So we would create a frequency distribution where we would have a table that has your grades on one side and the frequency on the other. And so in this case, you can make it a very rough sketch. My grades will consist of A, B, C, D, and F. Now what I need to do is come into my table and just simply count it up. So if I'm looking at A's, I'm going to count up all my A's. So I have 1, 2, 3, 4. And so the frequency of A's is 4. Same for B's, 1, 2, 3, and 4. So my B's are 4. My C's will be 5, my D's will be 3, and my F's will be 5. And that is all that we are getting at when we are talking about creating a frequency distribution. We are just looking at how is the data being distributed and in what kind of categories do we have to work with. Okay, so that's all there is to frequency distribution. Now let's look at this next problem here. So we have that the following table is going to give us some information. And it's giving us a grouped frequency distribution based on the weights of 194 babies. Answer the questions that follow based on the distribution. So if we look at it again, the first thing it wants to know is how many classes there are. Essentially, we're looking at how many columns do we have. So you count them up. 1, 2, 3, 4, 5, 6. So the number of classes is 6. Okay. Now the second part wants to know the class width. So remember, you can find your width based on either the lower or the upper class. It's completely up to you. So if we were to find the width and we make it based on my lower class, we would take 2 of my columns and we would find the difference. So I have 0 and 1, so I would have 1.00 minus 0.00 gives you 1.00. So this means my width is 1.00, and then always add your units if units are given. And in this case, we are talking about kilograms. Now, where did I get the fact that we're using kilograms? Well, I get it here from the problem where it says kilograms. You can also get it out of your table. Now, if we want to know the value of the lower class limits of the third class, what that means is we would count over 1, 2, 3. So my third class is going to go from 2.00 to 2.99. Remember, the lower class is the left-hand side, so in this case, my lower class would be 2.00 kilograms. The last one says, what is the relative frequency of the fourth class? Give your answer as a percentage rounded to the nearest tenth. So here I would count over 1, 2, 3, and 4. Okay. So here we are looking at that fourth class, which is going to go from 3.00 to 3.99. And in terms of frequency, it has 89 babies. Okay. Now that's not my percentage that I'm looking for. My relative frequency is going to be the frequency of your class divided by your total. So in this case, the frequency of my class is 89. My total was given as 194. So in this case, we are going to end up with 0.459. Since I want a percentage, we would simply multiply by 100, so this is going to be 45.9%. Alright, let's look at one last one. So here we have that Ring Cloud is a phone answering service, and the following data is given as calls per day reported. So here I've got all of these values, and the first part says create a grouped frequency distribution for the data using 8 classes, and then use it to answer the following questions. Let the first lower class limit be 0 and the class width be 10. Okay, so first of all, I've already included this data table here to make life a little easier, but normally this might not be given. So the way you set it up is you have class and you have frequency. And when you're talking about classes, you'll use the information provided. So we are told that the first lower class must be 0. So if we look, that's exactly what's listed here is 0. We are then also told that the class width is 10. So if I look at my lower class is 0, and then I go to my second class, its lower class then should be 10, giving me a class width of 10. That makes my upper class to my first class a 9. Okay, so we also were told that we needed to have 8 classes. So here is 1, 2, 3, 4, 5, 6, 7, and 8. Now with this, I have to make my frequency. So the way you get your frequency is by coming into the data table and figuring out how many values fit. So here between 0 and 9, I had none. Between 10 and 19, you have 6. 20 to 29 is 8. 30 to 39 is 5. 40 to 49 is 4. 50 to 59 was 3, 60 to 69 was 5, and 70 to 79 was 4. Okay? So I now have the information I need. Now the second part wants us to calculate the relative frequencies for each class. Okay? So in order to do that, I need to figure out how many sets of data do I have here. Well, my total is going to be that I have 35 data points. Therefore, in each one of these, notice I have my class, but my relative frequency is going to be the frequency of my distribution divided by the total. So for this first one, we would have 0 divided by 35, but you always give it as a percentage, so this is 0%. Let me do one more and then I'll give you the rest and you can check yourself. So here, between 10 and 19, we're going to have 6 out of 35. When we do that, we're going to end up with 17.1%. The rest of the percentages are 22.9%, 14.3%, 11.4%, 8.6%, 14.3%, and 11.4%. Now I would highly recommend you go in and you calculate each one of these percentages by yourself just to make sure that you have a good comprehension on what it is we're doing. Now for these last two questions, it very simply goes back to relating to the work you already did. So first, for what percentage of the days is the number of calls between 40 to 49? So you look at 40 to 49 and that percentage here is going to be 11.4%. And then what is the most common range for the number of calls per day? So we're looking for your highest percentage, and that highest percentage falls from 20 to 29. So that is everything you need to get started in looking at data frequencies and frequency distribution. So if you have any question, please let me know. Otherwise, I look forward to seeing you next time.